Hypothesis theory and type 1 type 2 error is a basic for the inferential statistics. You cannot understand the statistics without this. Hi, my name is Pradeep Chavan and today we are going to see the theory and how to identify rather to eliminate type 1 and type 2 error. So which is required for the T test, Z test, so many tests which are used in the inferential statistics that we are going to see. So let us start. Hypothesis testing is a educated guess to detect the significant difference by comparing sample statistics and the population parameter. In hypothesis, there are two parts. One is a null hypothesis, second is a alternative hypothesis. So let us discuss more. Null and alternative hypothesis property. Null hypothesis, whatever sample we have taken, that is assumed that is a part of population. Nothing is changed, or we know about that sample with respect to population. So we have to test. If it is accepted, then it is okay. If it is not accepted, then it will be rejected, and alternative hypothesis will be followed, which is unknown, uncertain, means other options are available. So by definition, null and alternative hypotheses are opposite, mutually exclusive. The null is either rejected or it is not. Only if the null is rejected, we can proceed to the alternative hypothesis. Null and alternative hypothesis statement. All statistics inclusions are made in reference to null hypothesis. We either reject the null hypothesis or fail to reject. If we reject the null hypothesis, then we conclude data support the alternative hypothesis. However, if we fail to reject the null hypothesis, it does not mean we have proven the null hypothesis is true, and vice versa. That is, failure to reject the null hypothesis does not equate to proof about its truth. There will be always type 1 and type 2 error will be always there, even if you reject or accept the null hypothesis. So it does not mean that there is a no error. So there will be always type 1 and type 2 error will be there. So what is that? Let us see in the next slide. Let us take example of type 1 error. You smell smoke. You think this is not normal. Reject your null hypothesis. Normal is a assumption, that is a you have to accept. Now here you are rejecting assumption that everything is okay. Therefore you pull the fire alarm. The building is evacuated and the fire department arrives to investigate. After the investigation, it is determined there is no fire. You falsely pulled the fire alarm when you rejected your assumption that everything is okay was okay when it is really was okay. You committed type 1 error, a false alarm. So type 1 error, rejection of the assumption when it should not have been rejected, incorrectly rejecting null hypothesis, in this case a false alarm. Let us talk about the type 2 error. You smell smoke. You think it is probably someone who burned their lunch in the microwave. No big deal. Therefore, you do not reject your assumption that everything is okay. You uphold the null. But there is indeed fire. No one is injured, but the building burns to the ground. When you fail to reject your assumption that everything was okay when it is really not okay, you committed type 2 error. What is a type 2 error? Failure to reject the assumption when it should have been rejected, incorrectly not rejecting null hypothesis. Just rewrite this hypothesis in tabular form. Now A0, no fire. Here we are assuming there is a nothing is change. So situation is normal, is as regular it is there. So no fire. That is A0. Alternative hypothesis is a fire. Now conclusion. Now no serious fire. and actual condition, there is a correct conclusion if there is a no serious fire. But if there is a serious fire, then type 2 error will be there. Are you getting me? Serious fire, you are concluding, and there is a no serious fire, that is a type 1 error, and correct conclusion if there is a occurrence of the serious fire. Now see, this type 2 error is much greater or much fatal. Something is there, problematic there, and you are concluding there is a no problem. Whereas in type 1 error, you are overcautious, you can say. There is a no problem, but still you are saying there is a problem or there is a fire. Okay. On the lighter mode, type 1 error, the doctor is telling to the person, male person, that you are pregnant. That is a type 1 error. And type 2 error, lady is there who is already pregnant and doctor is saying that you are not pregnant. So here type 1 and type 2 error review can be seen. This is the actual condition. H0 is true. H alternative hypothesis is true. Here it is assumption or the conclusion, not assumption, it is a conclusion. Do not reject 0. If it is 2, then correctly inside non-rejection region. If you are lying here, then type 2 error will be there. Reject null hypothesis, type 1 error will be there if H0 is true, and reject H0, that is a conclusion. If alternate hypothesis is true, then it is okay, there is no error. Let us talk the causes of type 1 and type 2 error. So this is a diagram from which we can understand type 2 and type 1 error. Type 1 error is also called as alpha error and type 2 is also called as a beta error. Now this is a lot which is okay, but sample you have collected from the extreme end or the far out tail. So from that you are concluding lot is not okay. Actually lot is okay. So that is a alpha or the type 1 error. So second example, lot is already shifted. Now you are taking the sample from this red area and you are concluding. So these sample are okay because it is lying in this region, whereas the actual lot is not okay, which is already shifted. So you committed B error, beta error or the type 2 error. So what are the causes? Sample is in the far out tails of the sampling distribution. Our sampling technique is not correct or the wrong, and most common cause is a chance and chance alone. Now question is how to control type 1 and type 2 error. Type 1 error reduction, you can decrease the possibility of the type 1 error by reducing the level of significance. So this particular confidence level 95% you can increase to reduce the type 1 error. Okay. For the type 2 error reduction, one of the simplest method to increase the power of the test is to increase the sample size. So increase the sample size to reduce the type 2 error. And second method, increase the significant level. Now here we are saying the reduce the significant level. If we reduce the significant level, then type 1 error will be reduced, but type 2 or the beta error will be increased. So some kind of balance should be there. So that's why generally significance level is considered as a 0.5 or 95%. What are the type of hypothesis testing? There are two types. One is a two-tail test. Second one is a one-tail test. Again, one-tail test is divided into two parts: left tail test and right tail test. So here, two-tail test for the rejection region. Now, what is that? Now we have to calculate Z or the T depending upon the number of sample, and we have to assume that population and sample there is a no change. That is a alternative. Sorry, null hypothesis mu equal to mu zero, sample mean equal to population mean. So see whether that particular Z or T is lying in this non-rejection zone, then this will be the two-tail test. So if it is lying in the rejection zone, then null hypothesis will be rejected and alternative hypothesis will be accepted. This is one-tailed lower test rejection region. Here null hypothesis is lying. So we have to assume in this non-rejection region. So we have to calculate Z or T depend upon the sample and you have to see. If it is lying here, then null hypothesis is accepted. If it is lying outside the region, in this region, then alternative hypothesis is accepted. So this is the same as one tail lower test. Only thing is that it is at the upper stage, upper level. Now null hypothesis is that you have to assume that is lying in the non-rejection region here. So we have to calculate the value of Z and T, and if it is lying here, then null hypothesis is accepted. If it is lying outside the rejection, rather in rejection area here, then alternative hypothesis will be adopted. So that's all from my side. Thank you very much for joining this session. Thank you.